Hello everyone. Hello everyone. So today we are going to discuss problem lead code problem number 518, which is coin change 2. So in this problem you are given an array of coins and each coin is of different denomination, and you are also given an integer amount. And what you need to do is you need to return the total number of combinations that makes up that amount. Now you can also reuse the coins when you create a combinations that makes up that amount. And if you cannot make up that amount by any of the combination of the coins, then you need to return 0. So here we are given an example. We are given an amount 5 and we are given coins 1 to 5. Now you can reuse those coins in any combination, and you need to make an amount 5, and you need to find out how many such ways we can make the amount 5. So one way we can make amount 5 is just taking the coin of the amount 5 and then you can make it. Another way you can make it using the coins of denomination 2, two coins of denomination 2 and one coin of denomination 1. Another way is using one coin of denomination 2 and using three coins of denomination 1. And the last way of making it using all 5 coins of denomination 1, and you can make amount 5. So there are total 4 ways to make the amount 5 using these coins. Example 2, you need to make the amount 3 and the coins you are given is 2. So if you use 2 times, it makes amount 4, not 3. So there's no way you can make amount 3 using the coins of denomination 2. Here amount 10, coin given is 10. So there's only one way to make it. So output is 1. So now let's see. Let's try to see how we can do this. Okay. So now, yeah. So now let's see. You are given the coin 1, 2, and 5. And you need to make an amount which is 5. Now let's think how we can do it this. Now if I tell you that you need to find the different combination of this coins, I mean all the subsets of this coin. So you'll find 1, you'll find 1, 2, you'll find 1, 2, 5, you'll find 2, 5, and so on, right? These are all the subsets. But here the condition that we are given is we can repeat the coin. So when we make this amount 5, we can have 1 comma 1 comma 1 comma 1 comma 1, and we can still make this amount 5, right? So when we are finding the subset, what we are doing is we are taking this first element and we are doing it include and exclude. If you'll watch my other videos of finding the subset, I have explained that. So when you find the subset, what you do is uh, my pointer is here, and then I'm gonna include 1, and then I'm gonna exclude. So first I'm showing how to find the subset. Okay, so if I include 1, now my subset has this, and if I exclude 1, my subset is empty. Then my pointer is incremented here. Now my pointer is here to 2. So again I'm gonna do the same thing, include and exclude, and same thing, include and exclude, right? When I include 2, I have 1 comma 2 in my subset. When I exclude 2, I have 1. When I include 2, I have 2. When I exclude 2, I have empty. Then my pointer is here. Again, I'm going to do the same thing. Include, exclude for all of them. Okay. So when I include 5, I have 1, 2, and 5. When I exclude 5, I have 1, 2. When I include 5, I have 1, 5. When I exclude 5, I have 1. When I include 5, I have 2, 5. When I exclude 5, I have 2. When I include 5, I have 5. When I exclude 5, I have empty. So here we have found all 8 subset. Sorry, 5, 6, 7, 8. So here we have found all 8 subsets. We were given 3 elements and the number of subsets are 2 power n, which is 2 power 3, which is equal to 8. And so we have found all the 8 subsets. Now in this problem, we don't need to find the subset, but something similar. Here what we need to do is we can reuse the coins, right? So when I'm given 1, 2, and 5, and I need to make an amount which is equal to 5, and I can reuse the coin. So what I'm going to do is for 1, okay, I'm going to include 1, right, in my set, right? So when I include 1 in my set, what does the amount becomes? 5 minus 1. So my amount is equal to 4. And when I exclude 1, my pointer is here, okay? When I exclude 1, it's an empty set and my amount is 5, okay? Now whenever I'm including 1, right, what should my pointer in the subsets? We were incrementing the pointer, right? We were moving on to the next pointer, but here I'm including the 1. I can still use this 1 again and again, so I'm not going to increment this pointer, okay? My pointer for this will stay here only. So for this one, when I'm including 1, since I can reuse that 1 again and again, I'm not going to change my pointer here. My pointer will point to 1 only. Now here I'm excluding the 1. So now I'm excluding the 1. So in this case, I will increment my pointer. So this is the difference. In subset, what we were doing is we were incrementing the pointer. So first for this one, for this step, the pointer was pointing to 1 for the first step. And then we were incrementing the pointer to point to 2 for both of this case, and here we were incrementing the pointer to point to 5 for all of this case. So unlike subset, what I'm going to do is, since I can reuse that number again and again, I can reuse that 1. So I'm including 1, I can again include 1. So I'm not going to change my pointer. And then again, I'm going to do the same thing, include, exclude. So this time I'm going to do include and exclude, okay? So now if I include 1, I have 1, 1, and my amount will be 4 minus 1, which is 3, right? I'm not going to change pointer again because I'm including 1. And here I'm excluding 1. So my this will be, and A will be 4. And here I'm going to increment my pointer. So here my pointer will point to 2. When I exclude it, I increment the pointer. Otherwise, I don't increment the pointer. Now, same thing here, include and exclude. Okay. So when I'm doing include, my subset is 5. Okay, pointer is 2. So 5 minus 2. So I'm including 2. So my subset is 2. And the amount is 3. And since I'm including, I'm not going to change my pointer. It's going to point to 2. Now here I'm excluding. So here it would be empty set. A will be 5, and I'm going to increment my pointer because I'm excluding that element. So I'm gonna move to next element. Okay. So now here my pointer was pointing to 1 for this one. Okay. So now again same thing, include and exclude. So when I do include, so I'm going to include, my pointer is pointing to 1, I'm going to include 1. So now I have 1, 1 and 1, and my amount is 2. I'm again not going to change the pointer, it will still point to 1. But when I exclude it, I'm going to increment my pointer. So here 1, 1, amount is 3, and my pointer will be pointing to 2. Okay. So now let's see. Now let's do this one. If I do include here, I'm not going to change my pointer, so I'm including 2. So now this one has 1 and 2, and my amount is 2. 4 minus 2. So amount is 2. My pointer is going to still point at 2, but when I exclude it, my set has 1, my amount is 4, and my pointer is going to point to 5. Okay. Now for this one, when I do include, okay, my pointer is pointing to 2. So I'm including the element 2. Okay. So that's gonna give me 2 comma 2, and amount was 3. Now the amount is 1. And I'm not going to change my pointer, it will still point to 2. But for exclude, it will be 2, amount will be 3, but I need to increment my pointer to point to 5, right? And here include, when I do include, I'm going to include 5. So my amount is 0, and my pointer will be increment. I'm including, so I'm not gonna do anything with my pointer. It's still gonna point here. But now we reach here, so we're gonna have one base case. When my amount becomes 0, that means I have found one combination that adds up to that amount, and that combination is 5. So from this step, I'm going to return 1. I found one combination, so I'm going to return 1. Now let's do exclude. Okay, so if I do exclude, I still have empty set. My amount is equal to 5, and my pointer will be incremented. It was on 5, now it's gonna go out. I mean, it's gonna go out of bound, right? So whenever that happens, what I'm going to return is I'm going to return 0 because I don't have any more elements left, any more coins left. So I'm going to return 0 because now my index went out here. It's pointing here. There are no more coins left. So I'm going to return 0 here. Now, what the final answer, like from this set, my pointer was here, my amount was 5, and I need to make 5. So there is only one combination, which is including this 5, only one combination that I can make. So include plus exclude, we need to do plus, and I'm going to return 1 from here. 1. Okay. So now let's go here. Here again, I'm going to do include. When I do include, I'm going to have 1, 1, 1, 1. My amount is equal to 1. My pointer is still pointing to this one only. Let me write it here again. 1, 2, 5. My pointer is still pointing here. And here I'm going to do exclude. If I do exclude, I will have 1, 1, 1, amount is 2, and my pointer is going to point to 2 because I'm going to increment my pointer, right? So now if you look at these two problems, let me show you what I'm trying to show. Uh, okay, so if you look here, okay, if you look at this problem, where is it? Where did I lost it? This one and this one? No, no, I forgot. I lost it. Okay, let's continue. Let's do include and exclude here. So here I'm going to do include, okay? My pointer is pointing to 2. So I will have element 1, comma 1, comma 2. Amount will be equal to 1. My pointer will still be pointing at 2. When I do exclude, I will have 1, comma 1. My amount is 3 and my pointer is 1, 2, and 5. This one. Okay. So now if you look at this two problem, this one here I need to make an amount 3 using this set and I have only one element which is 5. Here I need to make an amount 3. I have only one element which is left which is 5. I need to use that and make an amount 3, which is not possible. But if you look at this two problem that I have underlined in green, those are overlapping sub problems. So I found overlapping sub problems in my implementation. Okay, I just wanted to show you that. Now again, so now we are here. My pointer is pointing to 2 and we are here. So I'm going to do include. Okay, so when I include 2, I will have 1, 2, 2, and 2 again. And my amount will be equal to 0. My pointer will still be pointing at 2, but still, since I have reached my amount 0, I'm considering that I'm able to find a combination which is 1, 2, 2. So I'm going to return 1 from here. I found one combination. Now let's do exclude here. When I do exclude, my set will be 1, 2. My amount will be 2. My pointer will be incremented. So 1, 2, 5, and I'm going to point to 5. Now let's do this one. Include for this one, okay? Include. Okay, so my pointer is pointing at 5. So when I do include 5, it's 1 and 5. Here my amount goes to -1. So my amount is negative and my pointer is still pointing at 5. Now, as soon as your amount goes to negative, that means you are not able to find the combination that adds up to that amount. So you are immediately return 0 in that case. Okay. Now, when I do exclude for this one, when I do exclude for this thing, okay, I'm doing exclude. Okay, so when I do exclude, right, my set will be 1, my amount will be 4, and my pointer will be incremented. Right now it's pointing to 5. It will be incremented. It will point to some index, out of bound index, and then I don't have any more coins left. So I'm going to return 0 from here. 0 plus 0 is 0. So this will return 0. And if you look at this combination, this thing, when our pointer is pointing to 5, when I include 5, my amount will go negative. When I exclude 5, the index will go here, like out of bound. So this is also going to return 0. You can solve by yourself and find out. 0 plus 1 is 1, so this is going to return 1. Now here, this one, we are pointing to 5, and we cannot make this amount using the coin 5. So this is also going to return 0. And here we are pointing to 2, and we need to make amount 5 using 2 and 5, which is not possible. Again, this is going to return 0, and therefore this thing where it's coming from, which is this, it is going to return 0. And this thing, 1 plus 0 is 1, so this thing is going to return 1. And let's see what happens here. So here I need to make an amount 3 using this coin 5. It's not going to be possible, so this is going to return 0. I need to make an amount 1, and my pointer is pointing to 2, and I have only 2 and 5 coins, so this is also not going to be possible. So this is going to return 0, and this is going to return 0. Now here I need to make an amount 2 using coin 2 and 5. That is possible. I can make one combination of such thing. So this is going to return 1. Here I can use one more coin and I can make amount 0. So this is also going to return 1. 1 plus 1 is 2. So this is going to return 2. Now if you look here, 2 plus 0 is 2. So this is going to return 2. Now 2 plus 1 plus 0 plus 1, which is 4. So sorry, 2 plus 1 is 3. So this is going to return 3. And 0 plus 1 is 1. So this is going to return 1. And 3 plus 1 is 4. So the final answer is 4. So that's how you solve it. Okay. So now if you look at this tree, right, each node has 2 branches. So the branching factor is 2 in this tree. The branching factor, each node has 2 branches. So the branching factor is 2. What is the height of tree? The height of tree is the amount, right? Because we are decrementing the amount until it becomes 0. So the height of tree is amount, right? So if you look at the time complexity to solve this way is 2. There is a branching factor raised to height, which is 2 power n. And space complexity is O of n, which is a height of tree. So if you look at this, this is nothing but a recursive approach. Okay. So I have a function. My function takes coins, that is an array of integer. It takes amount, and it takes the index, which points to the last array element, which is n. Okay. So if it's like this, 1, 2, 5, n is pointing here. Now my base cases. What are my base cases? Okay, my first base case. If I have amount of 0, that means I have a combination that adds up to that adds to that amount, so I'm going to return 1. But if my amount is less than 0, right? That means I cannot make that amount. So I'm going to return 0. And if my index, that is n, is less than 0, that means there are no more coins left for me to make that amount. So in that case also I'm going to return 0. And what are my recursive call? I'm going to do include. When I do include my coins array, I'm including that coin, so amount will be equal to amount minus coins of n, right? And I'm not going to do anything with the index when I'm including, right? Because I can still reuse this coin again and again and again. So not going to do anything with this. But when I do exclude, I am going to do coins. My amount don't change because I am not including that coin. I'm excluding that coin. But I'm going to decrement my index because I have excluded this coin. So that will become n minus 1. And what I'm going to return is I am going to return include plus exclude. So here what I'm doing is I'm taking this coin, I'm including this coin and I'm subtracting it from the amount. I'm excluding this coin and I'm not doing anything. And I'm making a recursive function call. And then I'm telling my subordinate, okay, I have included this coin 5. Now the amount is this and the coins you have is this. When I'm including, you still, my subordinate still have all of these coins left. So you still have all of these coins left. Now you go and try to find out how to make the remaining amount, how to make this remaining amount. And when I'm excluding it, that means I'm not subtracting anything from the amount, but I'm excluding this coin, right? That means I'm decrementing the index and I'm giving my subordinate 1, 2 and amount 5 and I'm asking him, you go and figure out if you can make this amount using these 2 coins and tell me the number of ways how you made those. So that's what I'm doing. Now let's write the recursive code in this Leet code. This is problem 518. Now let's write a recursive code here, okay? So this is Java. Okay, so what is our base case? Let's first write our base case. If my amount is equal to 0, that means I'm already found a combination that adds to that amount, so I'm going to return 1. But if my amount is less than 0, I cannot make that amount. Or my index, let me call a helper function, okay? My function, I need to call a helper recursive function because I need to pass an additional argument, which is the index. So n is equal to coins dot length minus 1. So I'm going to change helper function, right? This is a recursive function and that takes the coins, amount, and the index, okay? And this function returns integer and it takes an integer array coins, it takes integer amount and integer index, okay? Let's write our base case. If amount is equal to 0, that means I found a combination, so return 1. But if my amount is less than 0 or my index is less than 0, right? That means I am done with all the coins. I don't have any more coins left if my index is less than 0. I'm going to return 0 because there's no combination. There's no combination which can adds to that amount. And then I'm going to do include and exclude. Okay, so first I'm going to do include. So when I do include, I need to subtract from the amount. So coins of index, because I'm including that index, the coin at that index. Index stays as it is since I can reuse the coin. Plus exclude. Exclude will be coins. My amount is not changed, but I need to decrement the index because I'm excluding that coin. And that's it. So small. Let's submit it. Now the solution is gonna time out because our complexity is exponential 2 raised to amount. So it's not going to pass all the test cases and it did time out. Okay. So now in this case, okay, since it timed out, let's see what we can do. So here it already timed out. So let's work on optimization. Okay. Let's see how we can optimize the solution. Okay. So now in order to optimize the solution, what we are going to do is our solution already had an overlapping subproblems. Our solution had overlapping subproblems, right? Which I showed, right? When you had overlapping subproblems, you don't need to calculate those problem solutions to that problem again and again. It can save you some time. And our solution also had an optimal substructure. So if you found, like for example, if you have coin 1 and 2 left, and if you and you need to find how to make an amount 3 using those two coins. So the ways that you find, right? You're not going to find any better ways than what you are going to find, right? So whatever we are finding is the best way, it's or the best number of combination or the total number of combination to make that amount if you have that 1 and 2 left. There's no other answer other than that. Okay, so optimal substructure. So whenever you have these two things, you can convert your recursive solution into the DP solution. Now to convert the recursive solution into the DP solution, now you need to remember what were the changing parameters in this function, in the recursive function. What, which are the parameters that were changing? So this two, right? So that means you need a 2D table. Okay. Now, what are these parameters? It's an integer. So you need 2D integer table. Okay. And what is the amount? The amount goes from 0 to amount, right? And this index goes from 0 to n, right? Because we were saying that if index is less than 0, that means we are done with all the elements. So here we'll represent that with index 0. So index goes with 0 to n. So we need a 2D array of size amount plus 1 and n plus 1. What will be the return type? Whatever the function return type is. The function return type is integer. So our DP table will be integer. Okay. So now let's do that. So now we had this 1, 2, 5 and amount was 5. Okay. So let's create a DP table. Now since amount is equal to 5, okay, 0, 1, 2, 3, 4, 5, index 0, 1, 2 and 3. I made a big table. Let me erase it. I don't need this big table. I just need a small table. Okay. Okay. So this is our index. Okay. 0, 1, 2, 3. This is our amount. 0, 1, 2, 3, 4, 5. This is our amount. Okay. So now if you remember, our recursive function was doing like this. For include, it was doing coins, amount minus coins of index and then index. This was for include. And for exclude, it was doing coins, amount, and index minus 1. Okay, so this was for include and this was for exclude, right? So if you look at this, right, this amount minus coin index. So we are looking to, suppose for example, if we are populating the cells, I will be looking at row amount minus index, so something above me. Okay, and the column will be, the column that we are looking here at is the same column, and here the column we are looking the previous column, right? So we are looking at same column or the previous column, and all the rows about above that, right? So if I'm populating this cell, I might be looking at all these cells, right? That is what I'm doing. This is just to give an idea. So what we can do is we can do our iteration in a row major order, and row major order is also cache friendly. I have also told you in my other videos. The reason for that is whenever you fetch a row, the cache also fetches 10 other rows in the same line. So that is a cache friendly solution. Okay, so we are going to do that. And let's iterate in a row major order and see how this is going to populate. Okay, so let's do that. Okay, so now I'm going to iterate in a row major order one by one. Okay, so now the first thing, okay, now I need to populate my base case. So if my amount is 0, right? If my amount is 0, what we did in recursive function? We did that if the amount is 0, that means we already found a combination. So we're going to return true. So if the amount is 0, we're going to populate all the cell as 1. That is my base case, okay? Another base case was if my index is less than 0. So here our index is, if we cannot represent negative index, so I'm considering it as 0. So if my index is 0, I'm going to populate it as 0. Okay. If my index is 0, and so this will be 0. Okay. So now I'm going to start with this cell. Okay. So here the amount is 1. Okay. And my index is 1. Index 1 means it's pointing to this element. Okay, so if I do include, what is amount is 1, so 1 minus whatever the coin is at that index, so my amount becomes 0 and my index is gonna stay same, so 0 1. So for include, I need to look at this cell, the value of this cell, which is 1, so that is 1. And for exclude, my amount is 1, so I'm going to look at cell 1, and my index is also 1, so I'm going to look at cell 1. Oh wait, so for exclude, index minus 1, so I'm going to look at cell 1 0, which is this one, and the value is 0 for that one. So, and I'm going to do this addition, 1 plus 0 is 1, so this is 1. Now here, now for this cell, my amount is 1 and here the index is 2. So the element, the coin at that index is 2. So 1 minus 2 is negative. So my include will be 0 and my exclude is going to look at this cell. So 0 plus 1 is 1. Again here 1 minus this, it's negative. So include will be 0 and exclude will look at this element. So 1 plus 0 is 1. Then I'm going to look at this. Amount is 2 and this is 1. So 2 minus 1 is 1. So I'm going to look at cell 1, comma, and the index is 1, 1 comma 1, which is 1. So 1 plus 0, which is 1 for this one. 2 minus 2 is 0. So I'm going to look at 0, 1. 0, 1 is 1. So 1 plus 1, so here it's 2. And here 2 minus 5 because index 3, 5. So that is negative. So include is 0 and exclude is 2. 0 plus 2 is 2, right? And here 3 minus 1 is 2. So 2 comma 2 is the row, 2 comma this index of 1 plus 0, 1. 3 minus 2 is 1. So row 1. So 1 plus 1 is 2. And here 3 minus 5 is negative. So 0 plus 2 is 2, right? And when you come here, 4 minus 1 is 3. So row 3 and the same index. So 1 plus 0 is 1. 4 minus 2 is 2. So row 2 and same index. So 2 plus 1 is 3. 4 minus 5 is 1. So row 1, this 3 plus 1 is 4. Sorry, 4 minus 5 is negative. So 0 plus 3. So this will be 3. Here amount is 5, index 1. So 5 minus 1 is 1. So 1, the 1 and 0. So that will be 1. Here amount is 5. 5 minus 2 is 3. So 3, third row, 2 plus 1 is 3. 5 minus 5 is 0. So 0th row, which is 1 plus 3, which is 4. And your answer lies here. This is your answer, which is 4. Now, if you do this way, our TC is O of amount times N, and our SC, space complexity, is O of amount times N, right? So this is our TC and SC. Now, let's write the solution and see how if we are able to pass all the test cases here. Okay, let me reset this. And here I'm going to take a 2D array and the size will be amount plus 1 and N plus 1. Coins dot length integer amount plus 1 and plus 1, that is the size of our DP array, because these are all the different sub problems we need to calculate. We're gonna iterate in row major order. Less than equal to amount I plus plus, this is our row, which is nothing but it's the amount. And then for integer j is equal to 0, j less than equal to n, j plus plus, this is nothing but it's the index. And then our base case, what happens? if amount is equal to 0. So first base case is amount is equal to 0. So if I is equal to 0, then dp of I j is equal to 1, else if j is equal to 0, j is equal to 0, which is index less than 0. This is because our index 0th index represent negative index. So if that's the case, then dp of I j is equal to 0, right? So I is equal to 0, j is equal to 0, and else we're gonna do include and exclude. So integer include is equal to 0, and if amount minus coins, amount is I, okay, not this thing. So I minus coins of index, which is j, greater than equal to 0, that means our include will be equal to dp of I minus coins of j, that row, and column we are not decrementing the index, so index will be j, else our include will be, I mean, if that amount minus coins of index is less than 0, then our include will be 0, and exclude is equal to dp of, we are not changing the amount, we are decrementing the index, and then dp of I j is equal to include plus exclude, and out of this both the for loops we're gonna return dp of amount and n, which is the index. What is this? What is this bracket? This is else. Oh, this is outer for loop. Okay, so that's it. Let's submit it and let's see if it passes all the test cases. Uh, I minus, oh, I know what the problem is. So here, when we do I minus coin of j, our index is not 0 based. So we need to do j minus 1. The first element is at index 1 only. So, I mean, in array, the index starts from 0. So here we are saying that the first element is at index 1, but the array starts from 0. So we need to do j minus 1. And we also need to do j minus 1 here. And I think that's it. And there you go, our solution is accepted. So it's pretty simple. Once you have a recursive solution, converting to DP solution is just figuring out how to convert that recursive solution into the DP solution. It's like just copy pasting your recursive code into a DP solution. Thank you so much for watching the video.